ladies and gentlemen, my name is Abdurrahman Ali. Today, inshallah, I'm going to solve question number 3 in lecture 7 in power fluid fundamentals, lecture 7, control volume analysis. So, first of all, let's read the question. Water accelerated by a nozzle to 35 meter per second strikes the vertical back surface of a cart moving horizontally at a constant velocity of 10 meter per second in the flow direction. The mass flow rate of water through the stationary nozzle is 30 kg per second. After the strike, the water stream splatters off in all directions in the plane of the back surface. First of all, determine the force that needs to be applied by the brakes of the cart to prevent it from accelerating. Second, if this force were used to generate power instead of wasting it on the brakes, determine the maximum amount of power that could ideally be generated. So he's asking us to determine the force and in case if we don't want to waste this force and we need to use it for other form of power, we need to find it. So how can we solve this question? First of all, let's analyze this cart. So we know we are having this cart. Okay. And we need to apply the forces that coming to them. We know the jet, this is the force, the first force, which is 35 per meter seconds. Okay. And we know the cart is moving 10 meter per second. And we know that if we hit the brakes here, if we use the brakes, so the force is going to be like this because it's trying to stop the cart. So let's say here is the force for the brake. Okay. So now we need to find the relative velocity. So relative velocity, or R dot V, relative velocity, we can find it like this. We have 35 meter per second. It is hitting the wall here, or not the wall, it's the front of the cart, and it is moving it 10 meter per second. So we know 35 is lost because of hitting this one, and we are having 10 meter per second. So how many lost in velocity? So we know 35 minus 10 equal to 25 meter per second. So this is our lost, this is our relative velocity. Okay. So now we need to find the flow rate or mass flow rate. Okay, we are having this equation, mass flow rate over mass flow rate of the jet equal to relative velocity, which is this one, okay, over the velocity of the jet. So we need this mass flow rate, so we have to rearrange the equation. So mass flow rate equal to cross multiply, we can get this one for the jet, and multiplied by VR over V jet. So mass flow rate, it's gonna be 30 times 25 over 35. It's going to be 21.43 kilogram per seconds. So after we found our mass flow rate, now let's see our second equation, which is very important, which is the summation of all forces on the f-axis equal to summation of all forces on the on the outlet. This is beta times mass flow rate times V minus the summation of all in the inlet, beta mass flow rate times V. So now all the forces in the f-axis, we are having the F brakes. F brakes, it's on the left, so it's gonna be minus. So minus F brake equal to, we know there is nothing on the outlet, so we can cancel it. It's gonna be 0. Now for the inlet, we know that mass flow rate, which we find it here, so it's gonna be 21 minus 21.43 times the relative velocity, which is 25. So F brakes, or the force on the brake, is going to be minus with minuses will cancel, and 21.43 times 25, we're gonna get 535.8 Newton. Okay, so our first equation is solved. We found this one, the F brake. Now for the second question, he is asking for, if the force were used to generate power instead of wasting it on the brakes, determine the maximum amount of power that could ideally be generated. So we know the equation for power is equal to force times velocity. So power equal, we have the force, which is 535.8 times our velocity. We know it is 10. The velocity of the cart, don't forget, cart velocity, or the object velocity. So times 10. So power equal to 5358 watt. That's the answer. Thank you guys for watching. I hope inshallah to see you next time.